Okay, now this one is also about mother and child problem. Okay, so let's say we have if a person is a female and is a parent, then this person is someone's mother. Okay. Okay, this looks like a natural claim or natural definition of what is meant by a mother. But we are not doing this. We are not studying whether this is true or false. We are doing the translation. Okay. So let's say we have a proposition fx such that x is a female. We have another proposition, let's say px, and then this px is x is a parent. And then let's say we have a proposition mxy, x is the mother of y. And then we want to do the translation, assuming that the domain consists of all the people in the world. Okay, all the people. Okay, so female, I'm using F. Parent, I'm using P. And mother, I'm using M. So this is easier to memorize. So how do we do the translation? Okay, if a person, so whenever you have a person who is both, okay, very good. Whenever you have a person who is both female and a parent, then this person has to be someone's mother. Okay, there are a lot of concepts. So for every someone, okay. So how do we do the translation? So let's do the direct translation here together. Let's see if this works. Okay. So for every person, okay, for every person, you can give a variable that you like. You can use x, y, z, whatever. But so let's use x here. For every x, such that, okay, such that what? Such that fx, f is a female, and f is a parent. And f is a parent. Then, okay, then, this is then. If, then, right? So if you are scared, okay, so make a bracket here as well, okay, together. So that if x is a female and x is a parent, then what? This person is someone's mother. Okay, so we can find someone such that, someone, y, such that x is the mother of y. Is that okay? So this is how we do this is fun, right? Direct translation. You write down things in the same way as we speak. But notice that this is something that I also want to introduce to you. This is not the only way of writing this. So this is correct. I believe this is correct. But there is also another way. Look at this y. Look at this y. This y is like I first look at x because I read the sentence like this. For all x, that means that I'm going to examine this whole thing for different kinds of x. Okay. So once I fix x, I will check it. Once I fix another x, I will check it again. So I will check it for all the possible x. Now, when x is fixed, then later I will find another y. So that this part, I will check for all the possible y's here. Is that okay? So the timing is as long as the x is fixed before the y, then you can fix the y here, or you can actually fix the y here as well. So what I'm claiming is that we can rewrite this one in this way. For all x, instead of choosing y at this a very late moment, we can, at the beginning, we try to fix x, and once x is fixed, then we can immediately fix y now. And then in that case, you can make it like fx and px implies mxy. Is that okay? And then they are equivalent. Okay. As long as when you move this x, this y, you don't go over the for all, then this will be okay. And this is neater. It looks more tidy, right? Because you are putting all the quantifiers at the beginning, so people will understand, oh, okay, these are the things that you need to fix when you consider the whole sentence. Okay? Okay? Is that okay? Yeah, this is, let's do one more. Okay, the sentence itself is very easy. It says, every person has exactly one best friend. Okay. Yeah, the sentence makes sense, right? Best. You may try to do some ranking of your friends, and then, oh, this one is preferred to this one is preferred to this one. So every person, it looks like they will have, for each person, he or she will have one best friend. So it looks normal, right? Okay, again, we are not discussing whether this is true or false. We are doing the translation. So suppose that I give you a propositional function of bxy such that it says y is a best friend of x. Okay. So in this sense, it could be possible that one person may have two best friends, or three best friends, or four best friends, right? So bxy. So for instance, B, John, and Mary. It says that Mary is the best friend of John. But you can also say B, John, and Peter. Then in that case, Peter is also a best friend of John. Okay. Now, this is the sentence that we want to do a translation. And we want to translate this accurately using the given bxy. And we assume that the domain are all people. Okay. So how do we do? Now the most difficult part comes from this exactly. Okay, so let's omit this at the beginning, at this moment. If I'm saying that every person has one best friend, one means one or more, then in that case, then what should be the sentence look like? Every person, okay, has one best friend. It's not there exists a best friend who is, there is some person who is the best friend of everyone, okay? So which one goes first? For all goes first, or there exists go first? Which one? For all goes first, okay? So it's like for all x, we can find some y such that bxy. Okay, this means that more than one best friend for everyone. Okay. Okay, now let's add back this exactly. How we can ensure that this is exactly one best friend. So exactly. So if you want to say exactly, then here it says that there exists someone who is the best friend is not enough, because there may be 2 or 3 or 4 persons who are best friends. So how do you argue? So if you are a boy, let's say you are a boy, and then you are saying to a girl that I love only you, not the other girls. You are the only love of me. Okay. Then how can you prove that? Okay. What should you say? So this is what I think the sentence, the equivalent sentence is. You're saying that you love her, but then for any person who is not her, I won't love. Is that okay? In that sense, it means that I'm only loving one person. Is that okay? I love you, but I do not love any other person. Okay. Okay. So we have something like this. This is already means I love you. For all x there exists y, bxy. Okay. For all x there is some I love. And we need to fill in this part. And for every other person which is not equal to y, then I won't love. Is that okay? So here, for every x, so first of all, I fix y. Okay, there exists y. And then what? And then for every person, let's use shorthand notation to help us understand first, and then we translate back the shorthand notation later. For every person who is not y, so for every person who is not y, so we need, rather than x and y, we need another new person, right? Negation we need to use. And then I'm saying that we need to have one more variable. Does that make sense? So for every person, let's call it z, and then not equal to y, yeah, I don't love her. She's not my best friend. Not b x z. Is that okay? Does that make sense? So I will need to have one thing, at least someone that I love, at least someone to be my best friend. And then I will need another new condition. Anyone who is not y, who is not this best friend, is not my best friend. Okay? Okay, now the most difficult part is you need to understand, oh, this looks like an and rather than imply. So sometimes this is the difficult part. But it's not usually that difficult. There exists usually comes with and. For all, it usually comes with imply. Okay, and now here, this one, let's change the shorthand notation back. So this is like for every z, if z is not equal to y, this will imply not b x z. Is that okay? Is that okay? And what's more? Okay. What's more? This, for all z, you can move it to the left. Okay, you can even move this to the left here, as long as it is picked after you select the y. So the whole thing, you can move it. So this one, you can move it further to be here. For every x, there exists y for all z. So it reads like this. For every person x, there exists some other person y, such that for all other person z, we will have this condition to be true. bxy, so x will love y. X is the best friend of y. Y is the best friend of x. And once you fix this x and y here already, then whenever z is not equal to y, it will imply that z is not a best friend of x. Okay? Okay? Now getting this, okay, bracket. Okay, there is a bracket here. Okay. Getting this, I'm not saying that you should get this right at the beginning. This is not the usual way. The usual way is how we develop it step by step. First of all, use shorthand notation to make sure that you understand the meaning of the sentence. Next, convert the shorthand notation back into some non-shorthand notation like this. And finally, if you like, okay, to make it look beautiful, you put all the quantifiers together. And by moving the quantifiers, make sure that the for all cannot go through the that exists. And similarly, the that exists cannot go through the for all. So they have to be in the correct order. But for all can pass through for all. There exists can pass through there exists. Is that okay? So this is this one. Okay. Okay, let's do some mathematical translation. So we are talking about English. So here, let's do mathematical translation. So suppose that you have a statement. Someone says the sum of two positive integers is always positive. Okay. And then let us say I have a proposition Px such that x is a positive integer. Then is there a way to translate this? There can be a lot of translation. Suppose that also for simplicity, make it more complicated. Let's say x, the domain of x is all integers. Okay. So how the domain? Okay, the domain of this thing is all integers. Then is there a way to do? So what is meant by this? The sum of two positive integers. So the sum of any two positive integers, right? So you have two positive integers to consider. Let's call it x and y. We should look for there exists or we should look for all. The sum of two positive integers is always positive. It means that the sum of any choice of x and any choice of y, you should give a positive integer, right? Good. So it's for all is there exists. For all, very good. Yeah, thanks. Yeah. So we have for all x that we need to look at and for all y that we need to look at. So the sum, okay. So the sum will be another number. Let's call it z. Is that okay? Okay. And then we hope that this z is positive. Okay. So somehow we will have something like for all x. So let's make it a messy mind here. So we will need to have some for all x, for all y to talk about, right? So we need to have px, because it states p is positive. We also have some py, it states y is positive, right? We need to somehow a certain quantifier on z, I don't know, and then we need to talk about pz as well. So these are the things that we need to combine together. Is that okay? And then the relationship between x, y, z is equal to x plus y. Right? Right? Or you may not need z. Later we can change it. Okay, so let's make it a very clumsy way. Okay, so this is what I think. So for all x, for all y, you choose it. Okay, if x is positive and y is positive, then the resulting, let's call it z, is also positive. Is that okay? Okay. So let's do a clumsy way, see if it works. For all x, for all y, okay, if x and y are both positive, if x and y are both positive, very good, px and py, then there exists z which is equal to the sum of x plus y, pz. Is that okay? And then you are, okay, don't be afraid, whenever you write down something like this, you know that you can convert this. Okay, this is that exists Z such that Z is equal to x plus y and pz. Okay. And in fact, we can, okay, if you're okay with this, then we can actually, the Z is not that important because Z is a function of x and y, right? So this is what I'm going to do to simplify this a little bit. So I'm simply saying that this is P of x plus y. Does that make sense? So we remove a variable, so and then it has the same meaning. So for every x, for every y, whenever px and py are true, okay, then the px plus y will also be true. Is that okay? Okay. For all these, so there's some other examples in the lecture notes. Yeah, please study at home. Okay. They are challenging, but if you don't know how to solve it, you can send me emails, or you can refer to the textbook. The textbook also have a lot of examples. So these examples are mostly collected from the textbook. Okay. Okay, so how about we take a break first, and then we will talk about two more things about this logical predicate calculus. Okay.